maintenance. This means you don't have to invest in the testing infrastructure, and you can start testing your website application performance right away. And finally, we have multi-tenancy and resource pooling capabilities, which allow multiple customers to share the same infrastructure and applications with security and privacy. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. The cloud enables us to test multi-tenant systems, whether it be functional tests, performance tests, any data leak issues, security tests, and automation tests. With that being said, let's move on to the next slide. So in this new section, we will talk about how test labs have evolved, starting with physical servers, then having virtual machines and containers, and how it affects queue testing. But first, let's talk about cloud service offerings in the next slide. As with any cloud computing service, testing solutions come in the form of software as a service, platform as a service, and infrastructure as a service models. These models provide you with different levels of responsibility for, control over, and maintenance obligations related to your testing solutions. First, we have infrastructure as a service, which serves as the complete data centers framework, eliminating the need of resource-intense and on-site installations. So in other words, your cloud provider owns the hardware and is responsible for maintaining it and managing it. So you don't have to worry about any maintenance. Then we have platform as a service. It serves as a web-based environment where developers can build cloud apps. It provides a database, operating systems, and programming language that organizations can use to develop cloud-based software without having to maintain the underlying elements. And finally, we have software as a service. Software provided over the internet, nothing is installed on a local computer, tablet, or phone. Nobody is needed to manage things like patches or updates. It just works. The benefit of these services is simple. Servers do not have to be maintained in order to execute any test. And with that being said, now we will pass it on to Abram, and he would go into a deeper explanation of things.
Thanks, Alexa. Thanks, Salman. So this slide is the first thing. I'm sure everyone here, when they look at the slide, they have an idea as to what I'm going to talk about. So this is how our test labs have, have evolved over the years. Like if we go back 20 years, right? In fact, many companies, even now, when it comes to testing, say they're trying to set up a test rig for their Selenium tests or a performance test rig, right? They would mostly do physical servers. And we all know the challenges, or we all know the scramble that happens, right? We try to understand, okay, what's the production servers going to be? And we try to emulate that kind of environment, physical environment in our labs. But that was the day that, like back 20 years back, or 15 years back, that was the only option probably we had. Then came the virtual machines, right? So I think somewhere around 2006-07, VMware virtual machines were very popular. Now, most of it, although it was to set up application servers, testing had really not moved to virtual servers back then. But at least that was an option. But again, it had its own disadvantages. Even those disadvantages continue to be even today if you're doing it on the physical labs. It's licensing restrictions you have. If you want to set up, like say 10 virtual machines running Windows Server, you still need to go and secure your licenses, right? That's one. And again, it takes up space, computing capacity of your physical host. So those challenges are still there, although you don't need a physical server, but you still need a virtual machine running on a big physical box. But then around that time, actually, well, the cloud started. I think Amazon came up with this idea of cloud around 2000, 2002, if I'm not wrong. And then Google, Microsoft, 2008, 10. But essentially, as QEs, we started taking advantages of the cloud. And of course, then the virtual machines came along, the containers came along, which actually made a huge paradigm shift. And I'm going to talk about that in one of my slides. But where it really started shining, I think it was just around that time when the containers came along, which again, my dates could be a little off, but around 2014, 15, if I'm not wrong. Now, containers, when they came along, it was mostly on-prem, and it did provide a lot of flexibility when it came to setting up your test rigs or setting up your applications. If you want to spin up a quick application and you want to test it against, then containers provided a lot of that flexibility. But again, when you're trying to do everything on-prem, the challenges are physical servers, because containers need to run on some physical host. And you're kind of sometimes stuck on whether you have that many servers available and things like that. And even if they are available, you probably wouldn't have all the specs the same as what you need them to be. Although containers gives you that flexibility that every time you can spin it up just the same way. But I think containers on the cloud, which again, maybe in the last 3-4 years, that created a lot of buzz within the testing community, within the QE community, in my opinion. A lot of the testing, in my opinion, started making that shift, especially when you're trying to test your applications as a part of a pipeline, right? You want to run your, say, some lightweight Selenium tests, smoke tests, or you want to do some throughput tests. So that's the time when you probably would think the first thing that would come to your mind is Docker, right? So and if the containers are running on the cloud, even better. If you're running your pipeline on the cloud, then spin it up in the cloud, and you don't have to really worry about which servers you're running it against. Maybe not, depending on what services you use. Now, not the last, but the container orchestration. Now, the slide that I have after this is actually talking about a use case where we use container orchestration. But I think container orchestration provided another level of flexibility. You can use containers, but you really do not need to worry about, say, the host on which the container is running. If it goes down, becomes unhealthy, then how do I know as a QE, if I'm running my test, how do I really know what's going on? So you actually offload your these activities to a container orchestration service, which would pretty much do that. All right. And of course, the latest and the greatest, which right now is making all the buzz, is serverless. Again, serverless brings up again a new dimension to testing. In fact, there are some YouTube videos out there which says, how do you set up Selenium test rig on AWS serverless environment? So that's this slide about. It's pretty much showing and charting out how the servers have evolved, or how the test lab generally has evolved over the years. So right from, we started with servers and now we are serverless. So a quick glimpse of that. Thanks, Salman. So now this slide is, since we're talking about this transition, we thought we'll do a quick use case as to doing things on-prem versus how things, testing gets much more effective if we move from on-prem to the cloud. So now, before getting too deep into this scenario, and again, before I even explain the scenario, I want to make it clear that everybody would have a different approach to solving a problem. So this was one approach that we thought could serve our purpose. So I'm going to briefly talk about that very high level, and we can certainly go into a little more deeper, maybe in some later presentations, right? But think about a scenario, think about this use case where you have an application, say a testing application, and that was actually this project about. A testing application that we had to build and it was targeted for school districts. So thousands and thousands of students would come online all at the same time and start a test. And they would take the test, maybe an hour long, maybe 2 hours long test, but everyone is logged in. All the users are logged in. There are multiple ways to solve this problem. One of the ways probably is, and that's something the conventional way, is to do it all local on physical servers. But the problem, and I'm sure a lot of you might have already guessed, was how do we, if the requirement is 40,000 users, which is not abnormal. Some of the school districts may have that many number of users all logged in at the same time taking a test. So how do you replicate that? If you want to do it on-prem, which is physical servers, it's not possible to get that many number of physical servers available. Or even if you want to do containers, it still needs some physical host. So how do you solve the problem online, on-prem? So the problem that the development team or the company was facing is, we have to test it. We want to see what 40,000 users does to our current production servers when they all log in at the same time. But then we do not have a way to generate that much load on-prem. Now let's do 5,000 and let's extrapolate the results. But extrapolation doesn't really work that way, right? It's not linear. So, but that was where we were stuck. So eventually, we tried a few options, and this is one of the options that worked for us. So the tool that we used for running the load tests was JMeter, and luckily JMeter Docker had a public image with the JMeter build. So we used to run a pipeline, which is step one, a CI pipeline that would take the Docker image, the latest Docker image, and build it with all the dependencies that we want it to be. We want the Docker file to be built it with, and then we'll store it into object storage. In our case, it was Amazon S3. Now it would pretty much run every day, just so that we are on the latest and greatest image of Docker. But the step two is where all the fun happens. In step two, depending on who wants to run the test, it could be a QE who wants to run, it could be a developer who wants to run, anybody in the team. So pretty much a QE has a Python script that he uses from the command line, triggers of the test. And essentially, there are a couple of services we use along the way. We use the message broker service of AWS, which pretty much, we break it up into messages, and these messages go into the SQS queue. And then once they go into the queue, there are some lambdas running, which is, which of course, the AWS lambdas, there are a bunch of AWS lambdas listening into the queue. They pick up those images. They send a signal to the ECS, which is the orchestration service. And again, if you see the managed service, I intentionally put in there, and that also brings up one of the strong capabilities of the cloud, is we really don't have to worry about ECS. We don't have to worry about SQS. Even the CI pipeline, if you're using a native CI pipeline of AWS or Azure or Google, we don't have to worry about that. Of course, we have to still write the stages and tasks for the pipeline, but we don't have to really worry about the uptime is guaranteed by those service providers. So the ECS picks up those messages and creates Docker instances. Now, that's the cluster of Docker images that you see on the right of the screen. Now, these Docker instances, which are ECS tasks, actually run and run the test against the application. The best part of this is the Docker, we don't really need to worry about, well, in this particular model, what you see on the slide, we actually had to make that calculation ourselves as to if we want to run, say, 500 Docker instances, and depending on what we think each of the image compute capacity will be, we do the calculation as to how many physical EC2 instance, which is virtual machines on AWS, we'll need, and we'll spin it up as part of ECS. There is a cost involved to it because we have these servers running, the EC2 instances, there is time involved because it spins up the EC2, spins it down, and then it starts all the Docker instances in each one of these EC2 instances. But still, it gave us what we needed in the project. We needed to run all the 40,000 users, 30,000 users, and we didn't really want to get into this extrapolate game of thinking, if for 5,000 users we get this result, what would be the results for 40,000 users, 50,000 users? So we decided, this pretty much gives us that flexibility. However, there is another level to it, which of course we didn't implement, but it would have been really cool if we did that, which is using the serverless approach, which is now the Docker here, of course, like I said, we use all the physical servers, which runs the Docker instances, and each one of them emulates the load to the application. But if we used Fargate, which is the serverless offering of the containerization service, then none of this we had to really worry about. Fargate would pretty much take up the do the heavy lifting. We don't even need to worry about which EC2 instances we really need to run the tests on. Fargate decides it. Of course, it's all automated. We have to run scripts, write scripts for that. But that's the power of cloud. So I think as a QE, where I got the benefit of this whole thing is I don't have to do the extrapolation. So 5,000 users, if there was any extrapolation that we had to do, then in the production, the results could be absolutely something different. Then it would things like that. I'm sure as QEs we all have gone through when we come to setting up similar testing solutions. So if you have any questions, of course, we'll wait to the end and we'll try to answer. But this use case was pretty much focused on this particular aspect of testing, where it could have been done on-prem, but cloud gives a completely different platform to do the test. Salman, we could go to the next one. All right, I think Vandy will speak to this slide.
Thank you, Amran. Yeah, so this is going to be a nice segue, what Amran was talking about. So I'm going to talk a little detail about the toolings. So most organizations are now leading towards adopting to the cloud because it's being flexible, scalability, and for the reduced cost. Using the cloud for testing has immensely helped organizations to acquire tooling like software licenses, infrastructures at a very low cost without even having to set up themselves and worry about the maximum utilization and etc. So here in the slide, if you see on the top left corner, which is Amazon EC2 instances, or it could be the Google Cloud engines, compute engines as well. So these are something which is similar to setting up a virtual machine, right, in your local and which spins up very fast, and you don't have to worry much about it. It's in few minutes and you can set up and you can go from there. The only thing is, like, there is no much difference what we are doing compared to the cloud and for the local. So that is one way of using Amazon EC2 instances as well. So if you come onto the bottom left corner, which is a Docker, and we are using, as Amrin was talking about, we can do some orchestration using Fargate, and we can control our environments. I'll come back to this section again, wherein which I'll talk a little bit about the advantages and disadvantages as well. Coming to the right side, which is about the SaaS environment. So this is pretty much set up everything for you. Since as a tester, I can write my test anywhere, just use these browsers. So it's like my test can be agnostic. So I'm writing in my local, but I can run this test on the cloud. So we have different kind of tools like Postman. We have Ready API. We also have the cross-browser testing using Sauce Labs, Browser Stack, and also AWS has a very good tool, which is a device firm. You just have to use these tools, how many ever users you have, and spin it up and use these services for running the test. So which is very flexible. You don't have to worry about what is going on. How do I have to set up? So it's just have to pick up a tool, pick up which browser you want to use it, and just spin up your test right there. It takes very little time, and you can execute it. The only big challenge for particularly SaaS is the performance of the application on the cloud. Sometimes, since you're using some private, specifically when you're using private cloud, the performance may be a little bit of challenge. So, and also because of many users are here, it is a shared service. and there could be delays. So, and also when it is coming to the outages, when we have any kind of outages, that also needs to be considered here. So like tester needs to anticipate like risks are like crashes, network breakdowns, and etc. But apart from that, there is no much maintenance need to be done for these services, which is easy to spin up and run your tests over there. So coming back to the Docker, which I was talking about on the left side, it's we as a tester, you have a control of what you want. What is the disadvantage with the SaaS? We don't have that kind of a disadvantage with this Docker spinning up, and so you have control of everything, control of the whole environment you have. So you can set up the whole environment, you can set up your Fargate, you can use Amazon EC2 instances and also EKS instances to set up the whole environment for yourself and the whole control. Instead of any environment going down, there is an outage, you have a control of how to figure it out and handle that. That is the advantage of using the Docker compared to the SaaS. So that is a little bit about the tooling. Coming to the rig on the cloud, I think Amran can take it from here.
Thanks, Wendy. Salman, I think you can, yeah. So this is again it's kind of a short summary of what Wendy talked about with the tools, and I touched upon regarding that use case and how the test labs have emerged. 1 second. So the test rig, once as QEs, when we're thinking, be it a Selenium test rig, a UI test automation test rig, or performance test rig, even running unit tests, well, not really, but generally for these end-to-end integration tests and system tests that we run, containers and container orchestration services is one that really shines. In fact, even though one might argue that we have EC2 instances that is all managed service, like Alexa in her slide talked about IaaS, infrastructure as a service. So we could probably use that as well. But again, somewhere costs come. We start thinking about the costs, about the uptime of these virtual machines running in the cloud. So this, as we are trying to think about test rigs in the cloud, I think this is the first thing that probably comes to our mind as to how we set it up. Cloud VMs, I kind of talked about that, but cloud VMs are essentially EC2 instances, or I think Google calls them compute instance. I don't really remember the term. And Azure calls it what, virtual machines? I don't know. But essentially, those are the cloud VMs that can be an alternate option. And again, it would depend on companies and projects how they implement it. At the end of the day, all we're trying to do is save money and keep it very agile as we are setting up these test environments, running our tests. We don't want that the infrastructure to bog it down. Cloud SaaS offering, and Vanny talked about it in detail. So many a times, maybe we are testing, we have an application, say in APIs. Our APIs live in AWS, but now in order to test an API, there would be multiple options. Either we set up something like, say, rest assured. We build up our own environment, rest assured infrastructure, and we want to set up our own virtual machines or Docker instances and run the tests as a part of in our own cloud. But the other offering also is the cloud SaaS offering, like Postman. Most of us would probably use Postman to validate our tests, our API calls, right? Or if not Postman, then Swagger or some other tool. But Postman has I think a pro license, which is the cloud offering license or SaaS license, which takes it to a whole new level. And I would encourage everyone to go and kind of spend some time. And I think they have a license period for it. They have a 15-day tryout license. So it's amazing. They do their own source control. They have Newman, that is their command line CLI, that you can actually write the tests, scripts in a CI pipeline and run the Postman test, even though it's not in your cloud. It's in the Postman cloud, but they give that SLA of how much time it will take for your test to run. So absolutely something that I would definitely encourage everyone to go and spend some time. So that's the cloud SaaS offering. Similarly, for even UI testing, browser stack automate. That's one of the awesome offerings that browser stack does through their cloud, where you can run your test and they take up, or they pretty much take all the heavy lifting. They set up your infrastructure. You have all these different requirements where you want to run your test on various form factors, devices, browsers, pretty much to do that. Private cloud. Private cloud is an option, and many companies do that as well. And one of the most popular private cloud offering is the Red Hat OpenShift. You know, if your company doesn't have any problem with how many servers they need in order to emulate a test or do a test or keep running tests, then private cloud is probably an option. But again, it doesn't take away the fact that you still need people to take care of the environment. You still need, there's a lot of work comes with it, but it gives you a cloud-like experience. You could pretty much do that while you're testing in the private cloud. Yeah. Okay. We're almost at the home stretch. So yeah, let's move to the next slide. Thank you. Cloud benefits. Cost. Absolutely number one. I think most companies or most projects that I have seen who move to the cloud, cost is one of the most important things. Now, if not well managed, again, many of us probably already have seen this, it kind of goes out of control. Many times you're spinning up servers. Say we spinned up a test server, right, to run a test, but we forgot to spin it down. So it's still billing. And at the end of the month, when you get that big fat bill from AWS, you know something was not right. So cost is still a big reason why development teams move. Rapidly deploy and test. Now, this is certainly, again, one of the as teams are moving, trying to be more agile, trying to build shift left, right? Trying to test as part of the pipeline, trying to test every bit of the way and make sure the code that's getting merged into the master branch is absolutely good and production ready all the time. So rapid test and deploy is absolutely important, and that's where cloud shines. And now, and it's also true that many companies would have Kubernetes-like orchestration, container orchestration environments locally built up that could probably give the same kind of quality. But then again, it all comes down to the fact that how much resources you have to manage that kind of environment. So but yeah, it's cloud-like environment, local or using a service provider like AWS. Repeatability, absolutely. So remember, again, being mostly QEs in the call, I'm sure we would have all seen this in our career, right? It happens. It works on my computer, right? So that thing is not a thing anymore, because if a QE is finding a defect, a bug, he's probably spinning up the environment using a script, right? A CloudFormation script or a Terraform script. He's spinning up that environment. Be it the virtual machines or the Docker instances, Docker containers, everything is built using a code. It exactly knows what kind of binaries needs to go, versions, and all that. And if you find a bug, and if you are still a developer runs the same script and spins up the same environment, there's nothing different, and he probably gets to see the bug. So repeatability is also one big factor of transitioning to the cloud. Was there? Yeah. And again, this is I'm kind of summarizing all that we've talked so far. The managed services, right? IaaS, and this was one of the slides where Alexa talked about PaaS, SaaS, we talked about SaaS, and of course, we talked about SaaS in context of all the testing solutions that offer this capability. But every service provider nowadays probably have the SaaS offering for the most part. Platform as a service and infrastructure as a service, those are some of the managed services that take testing and agility to a whole new level, if used the right way. So that's pretty much summarizes the cloud benefits. QE readiness. We wanted to talk about this. So again, as a QE member, right? And what we've seen, what I've seen generally is every cloud has some basic services that everyone is probably using, right? They would use storage, they would use security, which is IAM in AWS. They would use the compute services, which is EC2 instances, the virtual machines, and there are a host of other services. So essentially, what this a little bit of cloud familiarity of these basic services would, as quality engineers on the team, it helps to know what tests we need to come up with, or what is it that we test, how we need to really test, right? So this comes very handy. A starter level certification just adds to that. I think with in AWS, it is the cloud practitioner, if I'm not wrong. That comes very handy, at least to have some familiarity with some high level, with all the services that are there. So cloud is pretty much everything that we used to do in the past, but packaged in a different way. So that just helps. And the last thing that really helps is to know Python. So if you're on AWS, man, Python comes very handy. AWS is so Python friendly. They have this Botter3 SDK, which Python pretty much, so they made it Python friendly. So AWS is Python pretty much. Again, I'm pretty sure I have not worked that much on Azure, and anybody else can speak to it, but PowerShell, I'm sure they've built PowerShell. I'll see a lot of examples of Azure in PowerShell. Python as well. So Python, PowerShell, Golang, I think Golang is the Google language, but Python, PowerShell, those few scripting languages comes very handy as quality engineers to know what's going on. Even if you're writing some CI scripts, maybe there would be some Python bash script, things like that go into it. So, okay. I think we are almost towards the end of it. So what we did is we just created this section and 2 slides. This, and there's one more. We would as something that could be good takeaways for anyone who is interested to learn more. Like I talked about the Postman Cloud. Definitely, please go and spend some time and see what they're offering. And the first one, Browser Stack Automate for the Selenium. So these are excellent products from the SaaS offering from these providers. QE skills, we just put in some links in there for AWS, Azure, some of the certifications that we think might come handy for someone who's new to the cloud. This just sets the stage for anyone who is new, understand what offerings, how the cloud works, and just it just helps. So with that, I think we're pretty much done with our presentation. So I'll give it over to Salman. Salman, you want to take it off from here?
Yes, please. Thank you. Wow, that was great information. I do appreciate that for all of you guys. That was an excellent understanding on the cloud side. So we do have like a couple of questions, and I know some people were already answering, and I do appreciate that. This is why this is community, right? So we help each other out. So I do appreciate that. So the first question that came up, which I don't think anybody was able to answer, or maybe we can, could you suggest an approach to test application hosts on hybrid cloud? You're on mute if you're talking.
Oh yeah. So I could probably take a stab at it, and then anybody else could chime in. So who asked that question? So could you qualify a little bit as to what kind of testing you're looking for? Are you looking for functional, non-functional, what kind of testing? Well, let me just continue on this,
That
right?
was Sanjay Kumar who asked the question. Sorry.
Okay, so and again, when you say hybrid, I'm thinking that some of the services non-functional. Okay, that makes it easy, Sanjay. Thanks. So sometimes, and this is what I'm interpreting as hybrid, right? And you can correct me. So you have your application that's running on the cloud, but not everything runs on the cloud. Maybe your database is on-prem. Maybe your company or project is more comfortable setting up your test rig on-prem and firing it against the cloud. Is that how it is? Okay. In which case, there are pros and cons to doing this. And again, it's a need-based thing. So many times you may have all the infrastructure that you need on-prem, but you have your application on the cloud. You want to run it against the cloud. But non-functional tests, and that's where the catch is. When you're talking about non-functional, you want to make sure that your environment, every time you're running these tests, is the same the last time how you ran the tests, which means the network latency, there's no change in that. And that's the big part to it. So if there is a little bit of network lag between your last and this test, because after all, when you're having your test rig on-prem and your application on the cloud, you're actually going over the public internet. And that's where you might, your test results might not be dependable. There could be a little bit of delta every time, and it would be hard for you to, as a QE, to explain what's going wrong, right? So, and again, that's a battle you unfortunately have to fight, my friend.
Thank you.
But
I'm sorry to cut you off, but I got to move on to the next question.
Sure.
You have another
I'm
question,
not sure if that
which already been answered by Wendy, but I'll read that question for the contact. Can Kubernetes be integrated to Selenium Hub? And I believe,
yes.
Wendy, you already answered, and it said yes. So thank you very much. How did you configure Fargate to JMeter script? And somebody did answer that too.
Yeah,
on the chat.
Somebody answered yes.
Yep. And then last question, I believe this is the last question I'd seen on the chat, is what kind of new tests would you want to perform if you were testing a cloud native application instead of more traditional architect application?
To the question, what kind of new tests would you want to perform if you were testing a cloud native application instead of a more traditionally? Well, it's a very broad brush question. So one of the examples that I could tell, and this is from my experience, back on the on-prem days, I never used to, at least I never had a situation where I had to test the security, or the user access permissions and privileges of the entire environment. When I was running a test and I saw an error, it might bring up something, and then the IT might go and fix it. But most of these cloud providers, AWS or Azure, they have native tools. Like for IAM, which is access management, identity access management in AWS, there is a tool that you can actually simulate and test your environment. So you could probably call it a native cloud application testing. But apart from that, there are multiple, all these managed testing providers that you have. For example, back in the day, for performance testing, we would do perf mons, to see the CPU, the memory, the disk, and all that. But that's gone. In cloud, that is not a thing anymore. So AWS provides CloudWatch, Azure provides App Insights, I guess. So they have their own interface and own dashboards to run your own tests. So, and I think as you consider more and more services, I'm sure they will have their own interface how to test it. Even the SQS has its own interface, own APIs that you can write your test using Python. But I don't have a lot of experience on, I just have 3 or 4 services, but I think that was the question. I'm not sure if that was answered.
Another thing that I can think of is, so cloud is black box, right? I mean, we don't have any hold or control over what's up there, right? I mean, in my head, the idea is kind of still forming, but what I think of is when you're building an application on cloud, make sure, the logging is enabled, because you really don't have any other way of debugging, right? It's thoroughly logged. Also, you're building microservices, right? Multiple microservices.
Logging is a big part.
The possibility of failure is high, right? So, I mean, just to make, all I can think of is logging in my head, but does anybody else want to chime in?
Actually, you're right, Shri. Logging is definitely a big part. And yeah, I mean,
another thing is scalability, right? So when it comes to, so we have an application, we have microservices running on cloud. Let's say it's capable of initially handling about 100 users, right? We need to see at what point do we need to scale it, right? I mean, you start with 100, support for 100 or whatever, and at what point do you need to scale it? Another thing is mainly, right, some of our lambdas, okay? So for example, a lambda is that serverless function, right? They have this tendency to time out in 15 minutes, at least in AWS. Okay, I cannot think of, I don't know about Azure and other platforms. So if Lambda times out in 15 minutes, how can you kind of, make your application multi-threaded application so that it just doesn't wait for one Lambda to respond, right? These are more of an architectural level decision that probably comes out of your testing. Hey, dude, this Lambda's running, this Lambda's timing out. API gateway timeout of 30 seconds, right? How can you improve our parallelization so that, API gateway doesn't actually time out? I mean, you're running your process across multiple threads, or, you probably are using queues so that your response is asynchronous. Okay, so many different ways, but the idea behind is it's your testing that actually enables these change in your architectural decisions. Great point again, fault tolerance, right? I know we're almost at time.
And I could add quickly just one point to what Shri you just said. In like when back in the day, and even now, when we do our testing of performance, load, scalability on-prem, we just have servers, and then we decide, okay, in order to achieve what we want to, how much, how do we scale out or scale up? So, but in cloud, it is not a thing anymore. You decide, you decide, you define an auto scale group like in AWS, and you define something in the auto scale group that in my auto scale group, at the most, I can go up to say 5 servers. And then you say, okay, this is what the capacity I want to get in my application in peak time. And how should I really define my auto scale groups? So there's a little paradigm shift, but it's more or less the same thing. But logging we used to do even before, we still do logging. We still do scale up, scale down. We still do that, but it's just how paradigm shift in the cloud, how we do it.
Hey, thank you guys. I really appreciate for the answering, and I know we're kind of running short on time. But if you do have questions, anyone, please, I put my email address. You can email to me and I'll give it to the presenter and they can answer for you. So now the giveaway, right? That's the whole thing. So we want to give out some Amazon gift. And these are very simple, easy question that we came up with. And you can put this in the chat. It's multiple question. Name 3 services that cloud offer. And we went over this over and over. All 3 of the presenter went over this. If you can put it in, and we'll just go from there. And Shri, I'd like to turn this over to you.
Hey, Salman, thank you so much. I'm hoping you're actually looking at the winner.
Yeah, I am.
First and the second.
It's going crazy.
So the first and the second messages, Gustavo, you're not in, okay?
Yeah.
So, sorry. Manish, and I believe who's that? Vanaja?
Mrin. Mrin
Right,
is my
so
name.
you both get the gift cards. All right, so thanks for that piece. I know we spoke a little bit about slalom and slalom build and quality engineering practice within slalom build, right? I want to take a last 4 minutes to introduce Quality Engineering Academy to you, okay? Now, what is Build QE Academy? It's a 5-week training program that is designed for folks wanting to pursue their careers in quality engineering and immediately become a productive member of our global QE team at Slalom Build. At Slalom Build, our global QE team is about, I think we have about 250 quality engineers across the globe. And we are a very tight-knit community, solid Slack channels. We have like a great set of reusable artifacts, many things, right? So go through this 5-week training program that is basically curated and facilitated by our quality engineering experts, right? And become immediately productive. Now, this is probably our second or third year since we kicked off this academy program. And we have had some really solid QE engineers come out of academy. Now, the good news this year is that Quality Engineering Academy is being hosted in 2 locations, Houston and Charlotte, okay? Now, who's this designed for? Say you're a university grad, say you're a boot camp grad, or say you want to shift your career from what you're currently doing into quality engineering. You're a software engineer, you're a cloud engineer, you're a data person, you have solid tech chops, you want to move into quality engineering, this program's for you, right? Or say you are a software tester who's predominantly done some manual testing, but wants to explore, the engineering side of quality. This is for you, right? And what do you learn? What do you learn? Everything our quality engineer does on a day-to-day basis, right? Test strategies, test design, development, working on CI/CD pipelines, performance testing, UI and API automation, native mobile apps, just to name a few. It's almost like, it's like a Swiss Army knife of the chops that you need in order to become productive as a QE on day 1, right? Now, what does this mean? Here's the plug coming in, right? What does this mean in this group? We are hiring, right? So now if you are interested, or if you know someone who would be a great fit for this academy program, this link here is where you'd send your resumes to. Okay, so it's jobs.slalombuild.com. What we'll also do is we'll end up posting this job link on the meetup page. Or if you have questions, you can reach out to QEacademy@slalom.com. Now, let's say you have more questions and you want to talk to a leader directly, right? This person, Richard Hand. Richard Hand is a director out of Houston from Quality Engineering Practice. He is the leader of QE practice in Houston. His email address is richard.hand@slalom.com. That's a face you cannot forget. So go to LinkedIn, reach out to him, or if you have any more questions. And with that, I want to kind of, we are right at time, and I want to quickly open it up for any questions regarding, QE Academy or build or quality engineering, literally like 30 seconds. Any questions? Right. You can always reach out to Richard Hand. Remember, he's the person. Right.
And I also put my email address too, just in case if you guys need to reach out for another questions or anything like that. But we do appreciate that. Thank you very much, guys. Thank you. Great job, everyone. Thank you very much. Talk to you later. Bye.
Thanks, everyone. Have a nice day.
Bye-bye.